Hello everyone. In previous class, we have learned how to prepare the forward difference table. Now let us see the Newton's forward interpolation formula. So this formula is used to estimate an unknown value when the x values are equally spaced and the required value is close to the first observation. So before applying the formula, we should know the meaning of each symbol. Here, x naught represents the first value of x. So x is the value that we want to estimate. The symbol h represents the common interval or common difference between two consecutive x values. So what is mean by consecutive x values? So consecutive means one value followed immediately by the next value. For example, if the x values are 10, 20, 30 and 40, then 20 minus 10 is 10 and 30 minus 20 is also 10. So therefore 40 minus 30 is also 10. So therefore the common difference is 10. So this is the h value and the value p is calculated using the formula p equal to x minus x naught by h. So after finding the value of p, we apply it into the interpolation formula along with the forward difference from the difference table. So here consider three data points. The interpolation polynomial is of degree 2. So the first term is simply y naught. The second term contains the first forward difference represented by delta y naught. The third term contains the second forward difference represented by del square y naught. So as the order of the difference increases, the coefficient also changes accordingly. So next we see point number 1. If the number of data pairs increases, the number of terms in the interpolation formula also increases. For example, if we have only 3 data points, so the formula contains 3 terms. If we have 4 data points, one more term is added to the formula. So as the amount of data increases, the interpolation polynomial becomes larger. Next point 2. In second point, suppose problems contain n plus 1 data points. Then the interpolation polynomial will also contain n plus 1 terms. For example, if there are 3 data points, so the formula has 3 terms. If there are 4 data points, the formula has 4 terms. If there are 5 data points, the formula has 5 terms. So the number of data points and the number of terms in the formula are always the same. The third point is about the degree of the polynomial. If the data contain n plus 1 data points, then the interpolation polynomial is of degree n. For example, two data points produce a first degree polynomial, which is a straight line. Three data points produce a second degree polynomial, which is a quadratic curve. Then four data points produce a third degree polynomial, which is a cubic curve. So remember, if there are n plus 1 data points, then the degree of the interpolation polynomial is n. So now let us move to example 1. So here we are asked to find the value of sine 52 degree using Newton's forward interpolation formula. So the given values are 45 degree, 50 degree, 55 degrees and 60 degrees. So the corresponding values of sine x are also given. So our objective is to estimate sine 52 degree. So before doing the calculation, make sure your calculator is set to degree mode. If it is in radian mode, your answer will be incorrect. So now before applying the formula, let us check whether Newton's forward method can be used. So observe the x values carefully. The interval between consecutive x values 50 degree minus 45 equals to 5 degree. Then 55 minus 50 equals 5 degree. Then 60 minus 55 also equals 5 degree. Since all the intervals are equal, the first condition is satisfied. So also the required value 52 degree is closer to 45 degree. So which is the beginning of the table. Therefore, Newton's forward interpolation method is appropriate method for solving this problem. So now let us prepare the forward difference table. The first two columns contain the given values of x and y equal to sin x. So next we calculate the first forward difference. The first forward difference is delta y naught equal to y1 minus y naught. Similarly, delta y1 equal to y2 minus y1, which is 0.0532. Then next delta y2 equal to y3 minus y2, so which is 0.0468. Once the first difference are ready, so we calculate the second forward differences. The first second order difference is delta squared y naught equal to delta y1 minus delta y naught. So similarly, we calculate the remaining second order difference. So finally, we calculate the third forward difference by subtracting two consecutive second order differences. So now our forward difference table is complete. So using this table, we can calculate the value of P and apply Newton's forward interpolation formula. Since four pairs of data are given, so we use the Newton's forward interpolation polynomial of degree 3. So we have four data points, therefore we use the four-term interpolation formula. Now let us substitute the given values into the formula. So first we need to calculate the value of P. So P equal to x minus x naught by h. So the required value of x equal to 52 degree. The first x value is x naught equal to 45 degree and the common interval h is equal to 5 degree. So substituting these values, the value of P is 1.4. Now substitute all the known values into Newton's forward interpolation formula. The first term is simply y naught, so which is 0.7071. The second term is P into delta y naught. So here we substitute P equal to 1.4 and delta y naught equal to 0.0589. The third term is P into P minus 1 divided by 2 factorial into delta squared y naught. So here P minus 1 equal to 0.4. So and the second forward difference is minus 0.0057. So finally, the fourth term is P into P minus 1, P minus 2 by 3 factorial into delta power 3 y naught. So P minus 2 equal to 1.4, 1.4 minus 2 equal to 0.6. So in the forward method, choose the values from the top of the difference table. So we substitute these values together with the third forward difference minus 0.0007. So after evaluating each term and adding them together, so we obtained f of 52 degree equal to 0.7879. So therefore, the estimated value of sine 52 degree using Newton's forward interpolation method is 0.7879. So now the estimated value is 0.7879. Next, let us calculate the error. The error is the difference between actual value and numerical value. So from the trigonometric table, the actual value of sine 52 degree is 0.7880 or the calculated value sine 52 degree is 0.7880. So our interpolated value is 0.7879. So subtracting these two values, we get 0.0001. So the error is 0.0001. So the error is very small. So now let us solve this problem using backward interpolation method. So first, observe the given data. We have the values of x and the corresponding values of f of x. The given x values are 1891 to 1931 and the corresponding function values are 46 to 101. So our objective is to estimate the values of f of 1925. So first one, so why do we use the Newton's backward interpolation? Before choosing the interpolation formula, we check the position of the required value. The required value is 1925. So it is closer to the last value. So 1931. Then to the first value 1891. So therefore Newton's backward interpolation method is the appropriate method for solving these problems. So next let us calculate the common interval denoted by h. So the difference between two consecutive x value is x1 minus x2 which is 10. Then similarly x2 minus x1 is also 10. So since all the intervals are equal, so the common interval is h is equal to 10. So first write the x values and the corresponding y values in the first two columns. Next we calculate the first backward differences. So to calculate the first backward difference, we subtract the previous y value from the current y value. For example, 66 minus 46 is equal to 20. Similarly, 81 minus 66 equals 15. 93 minus 81 equals 12. 101 minus 93 equals 8. So these values form the first backward difference column represented by del y. Now let us calculate the second backward differences, and we calculate the third backward differences, and finally we calculate the fourth backward difference. So backward method, choose the values from the bottom of the difference table. Then simplify each term one by one. Finally add all the terms together. So after completing the calculation, we obtain f of 1925 equal to 96.8368. So therefore, the estimated value of f of 1925 using Newton's backward interpolation method is 96.8368. So thank you for watching. So I hope you understand today's concept clearly. So see you in the next video. Thank you.